Hi everyone. In the previous lecture, we have solved some examples from exercise 5.1. Now today, we solve the remaining examples from the exercise 5.1. The question number 10 from exercise 5.1. If AB bar is equal to 2i cap plus 2i cap minus 4j cap plus 7k cap and initial point A is 150, having coordinates 150. Find the terminal point. Find the terminal point. Find the terminal point B. See here. Here, vector AB is given and initial point is given. We have to find out terminal point. That is, we have to find out the coordinates of point B. So, see here. Let AB bar is equal to 2i cap minus 4j cap plus 7k cap. This AB bar is given. What is given also? Point A is given, that is 150. 150. We have to find out the point B. See, suppose point A is here, whose coordinates are 150, and point B is here. Suppose this point here, the vector along these 2 points is given. Let point B, that is terminal point, is suppose x, y, z. Point B is suppose x, y, z. Point A is here, point B is here. So therefore, or consider here, let A bar comma B bar be the position vectors of capital A and capital B respectively. Means point A is the position vector of the point capital A and B bar is the position vector of the point capital B respectively. So, as A bar is the position vector of the point A, so therefore, we have A bar is equal to, see, I cap, 1 into I cap plus 5 into j cap, that is 5j cap plus 0 into k cap. This is A bar. Similarly, B bar. See, the coordinates of point B are x, y, z. So, B bar is equal to x into I cap plus y into j cap plus z into k cap. So, it is x into I cap plus y into j cap plus z into k cap. Now, in three-dimensional geometry, we have seen if we have 2 points in the space, then the vector along them, that we have seen in the previous lecture. So, using that definition, here AB bar is equal to position vector of the point B, that is B bar, minus position vector of the point A, that is A bar. So, it is equal to, what is A bar? I cap plus 5j cap plus 0 into k cap No, so it is B bar minus A bar. So B bar is x into I cap plus y into j cap plus z into k cap minus a bar. Now we have to write here a bar, and that is I cap plus 5j cap plus 0 into k cap. It is equal to, when we take the subtraction of two vectors, so we have to subtract their corresponding components. Corresponding components means components of I, j, k. So see here, x into I cap minus I cap, so it become x minus 1 into I cap plus y into j cap minus 5 j cap, so it is y minus 5 into j cap plus z into k cap minus 0 into k cap, that is z minus 0 into k cap. So it is equal to x minus 1 into I cap plus y minus 5 into j cap plus z into k cap. This is your AB bar. This is your AB bar, but AB bar is given, but it is given to be 2I cap minus 4j cap plus 7k cap, but AB bar is equal to 2I cap minus 4j cap plus 7k cap. So therefore 2I cap minus 4j cap plus 7k cap is equal to, here it is AB bar, x minus 1 into I cap plus y minus 5 into j cap plus z into k cap. Now see here, on left hand side there is a vector in the form of ijk, on right hand side also there is a vector in the form of ijk, and these two vectors are equal. It means that their corresponding components means components of I cap, j cap and k cap are equal. By equality of vector, by equality of vectors, 2 is equal to x minus 1, minus 4 is equal to y minus 5, and 7 is equal to z. So therefore from this equation x is equal to 3. From this equation shift this minus 5 here, so plus 5 minus 4 become 1, so y is equal to 1, and from the last one z is equal to 7. So x is equal to 3, y is equal to 1, and z is equal to 7. But here we have considered the coordinates of point B are x, y, z. So therefore the point B is 3, 1, 7, and this is the terminal point. So therefore the terminal point B is 3, 1, 3, 1, 7. So this is the solution for question number 10. Now we see next question. Question 11 from exercise 5.1. Show that the following points are collinear. Show that the points A 3, 2, minus 4, A 3, 2, minus 4, comma B 9, 8, minus 10, and C minus 2, minus 3, 1, and the point C minus 2, minus 3, 1 are collinear. See here, we have to show that these 3 points are collinear. Means we have to show that these 3 points lies on the same line. Let A bar, B bar and C bar, small a bar, B bar, C bar be the position vectors of point A, B, C respectively. So as A bar is the position vector of the point A, so we can write A bar. So therefore, A bar is equal to, see, 3 2 minus 4, so it is 3 I cap plus 2 J cap minus 4 K cap. B bar is 9 I cap plus 8 J cap minus 10 K cap. And C bar is equal to minus 2 I cap minus 3 J cap plus K cap. Now we have to show that 3 points are collinear. So from these 3 points we get 2 vectors, AB bar and BC bar, or AB bar and AC bar. Any pair, AB bar, BC bar or AB bar, AC bar, if we show these 2 vectors are collinear, then from that we conclude the 3 points are collinear. So first we find AB bar. AB bar is equal to, see, position vector of the point B, position vector of the point B, that is B bar, minus position vector of the point A, that is A bar. So it is B bar minus A bar. Now here B bar is here, B bar minus A bar. So see here, 9 minus 3, 6 I cap. 9 B bar minus A bar, 9 I cap minus 3 I cap, 6 I cap. 8 J cap minus 2 J cap plus 6 J cap, and minus 10 K cap, minus minus become plus 4 K cap, so it is minus 6 K cap. This is your AB bar. Now we find here AC bar. AC bar means position vector of the point C, that is C bar, minus position vector of the point A, that is A bar. C bar minus A bar. C bar minus A bar. Minus 2 I cap and minus 3 I cap minus 5 I cap. Minus 3 J cap and minus 2 J cap minus 5 J cap. K cap minus minus become plus, K cap plus 4 K cap, 5 K cap. So this is AB bar and AC bar. Now again it is equal to, can I write it as AC bar is equal to, if we take minus 5 common here, then it is minus 5 in bracket I cap plus J cap plus minus 5, it become minus I cap plus minus 5, we have taken common from 3 terms, so minus 5 is outside the bracket, plus I cap is remain in the bracket. Here minus 5 is outside the bracket, plus J cap is in the bracket. Now here minus 5 is outside the bracket, so minus K cap is inside the bracket. So again it is equal to, AC bar is equal to minus 5 into I cap plus J cap minus K cap. See here AC bar is equal to, we proceed further, AC bar is equal to minus 5 in bracket I cap plus J cap minus K cap. Again it is equal to, if we multiply and divide it by 6, if we multiply and divide it by 6, we know that if we divide and multiply to any equation or any expression by same number, so the value of that expression doesn't change. So here multiply to right hand side by 6 as well as divide it by 6. So it is minus 5 into 6 I cap plus 6 J cap minus 6 K cap divided by 6. So it is equal to minus 5 by 6 into 6 I cap plus 6j cap minus 6k cap. But observe here, what is 6i cap plus 6j cap minus 6k cap? It is AB bar. It is AB bar. So it is minus 5 upon 6 into AB bar. And on the left hand side we have AC bar. So AC bar is equal to minus 5 upon 6 into AB bar. Now here AC bar is the scalar multiple of AB bar. AC bar is scalar multiple of AB bar. So therefore AC bar and AB bar are collinear vectors. This shows that AC bar is scalar multiple of AB bar. So therefore AB bar and AC bar are collinear. AB bar and AC bar are collinear. It means that they lies on the same line or they are parallel to the same line. But if we observe AB bar and AC bar, there is one point common, A. So they are not parallel, they lies on the same line. But point A is in common. So therefore the points A, B, C are collinear. So in this way we can show any 3 points are collinear. So here I have taken AB bar and AC bar. You may take AB bar, BC bar also and show that either AB bar is scalar multiple of BC bar or BC bar is scalar multiple of AB bar. Once we show this is the proof of collinearity of 3 points. So here this is the complete solution for question number 11. Now we see next question, question number 12 from the same exercise. If the vectors 2i cap minus q into j cap plus 3k cap, comma 4i cap minus 5j cap, 4i cap minus 5j cap plus 6k cap are collinear, then find the value of q. Are collinear, then find the value of q. Are collinear, then find the value of q. Then find the value of q. Okay. Before solving this example, I have repeat the concept. Suppose we have two vectors A bar, A1i cap plus A2j cap plus A3k cap, and one another vector B bar, which is B1i cap plus B2j cap plus B3k cap. And these two, A bar and B bar, are collinear. If these two vectors are collinear, then the coefficients of ijk in A bar and B bar are in proportional. If two vectors are collinear, then the coefficients means components of ijk in A bar and B bar are in proportional. It means that here A1 upon B1 is equal to A2 upon B2 is equal to A3 upon B3. So this holds. If two vectors are collinear. Okay, now come to the point. Now here two vectors are given. So first we consider, let A bar is equal to 2i cap minus qj cap plus 3k cap, and B bar is equal to 4i cap minus 5j cap plus 6k cap. Since A bar comma B bar are collinear vectors, and as I have explained here, if two vectors are collinear, then their components of ijk are in proportional. Collinear vectors, comma, the components of I cap, j cap and k cap in A bar comma B bar are proportional, and so therefore we get 2 divided by 4. See, coefficient of I cap in A bar is 2 and coefficient of I cap in B bar is 4. So 2 divided by 4 is equal to coefficient of j cap in A bar, that is minus q, divided by coefficient of j cap in B bar, that is minus 5, is equal to coefficient of k cap in A bar, that is 3, divided by coefficient of k cap in B bar, that is 6. So that is 2 by 4, 1 by 2 is equal to q by 5 is equal to 1 by 2. So therefore q upon 5 is equal to 1 by 2. Now q upon 5 is equal to 1 by 2. So therefore q is equal to, shift this 5 to right hand side. So we get 5 by 2. So therefore the value of q is 5 by 2. Here the value of q is 5 by 2. This is the solution for question number 12. This is question 12 from exercise 5.1. Next question. Question 13. Here we have to show 4 points are coplanar, and this can be shown. This can be shown by proving the three vectors from these 4 points are coplanar. It can be shown by proving the 3 vectors from these 4 points are coplanar. Means here we have to show AB bar, AC bar and AD bar. If these 3 vectors are coplanar, then automatically 4 points are coplanar. So we will see it one by one. Let small a bar, B bar, C bar and D bar be the position vectors of points A, B, C, D respectively. Means point A bar is the position vector of point A, B bar is the position vector of the point B, and so on. Now here A bar. See, point A is here, 1 minus 1, 1. So its position vector A bar is equal to I cap minus J cap plus K cap. B bar is equal to minus I cap plus J cap plus K cap. C bar is equal to I cap plus J cap plus K cap. And D bar is equal to, see here, 2I cap minus 3J cap plus 4K cap. This is your D bar. Now find out AB bar, AC bar and AD bar. Now AB bar, it is equal to B bar minus A bar. B bar minus A bar. AB bar is position vector of the point B, B bar, minus position vector of the point A, A bar. B bar minus A bar. See here, B bar minus A bar. So minus 1, it is minus 2 into I cap. Minus I cap, minus I cap, minus 2I cap. J cap, minus minus become plus, J cap plus J cap, 2J cap. K cap minus K cap, 0 K cap. AB bar. Now AC bar, it is C bar minus A bar. C bar minus A bar. Where is C bar? C bar is here. C bar minus A bar, 1 minus 1, 0. So it is 0 into I cap. 0 into I cap. J cap minus minus become plus here. J cap plus J cap, 2J cap. And K cap minus K cap plus 0 into K cap. This is AC bar. Now AD bar. Position vector of the point D, that is D bar, minus position vector of the point A, that is A bar. So D bar minus A bar, and it is equal to, see, D bar minus A bar, 2 I cap minus I cap, I cap. Minus 3J cap and minus minus become plus, minus 3J cap plus J cap, that is minus 2J cap. 4K cap minus K cap, 4K cap minus K cap become plus 3K cap. So this is AD bar, I cap minus 2J cap plus 3K cap. Okay. Now, as I have told you that to prove 4 points are coplanar, we have to show AB bar, AC bar and AD bar are coplanar vectors. And we know that the 3 vectors are coplanar, then any one of them is the linear combination of other two. If 3 vectors are coplanar, then any one of them is the linear combination of other two. Here we have to show that these 3 vectors AB bar, AC bar and AD bar are coplanar. So AB bar must be the linear combination of AC bar and AD bar. Then and then only these 3 vectors are coplanar, and once these 3 vectors are coplanar, the 4 points are coplanar. So right here, if A bar, point A, B, C, D are coplanar, then there exist unique scalars. There exist unique scalars x comma y such that AB bar is equal to x into AC bar plus y into AD bar. AB bar is equal to x into AC bar plus y into AD bar. If we get such two values x and y, unique values, then we can say that 3 vectors are coplanar. So let's find x and y. AB bar is equal to, now here the value of AB bar is also known. See, AB bar is minus 2i cap plus 2j cap plus 0 into k cap is equal to x into AC bar. What is AC bar? 0 into I cap plus 2j cap plus 0 into k cap plus y into AD bar. What is AD bar? I cap minus 2j cap plus 3k cap. Okay. Now on left hand side, multiply to first bracket by x and then second bracket by y and collect the components of I, j, k together. So we get here, after collecting components of I, j, k together, we get x into 0, 0 plus y into I cap, 0 plus y, that is y, so it is y into I cap plus x into 2, 2x plus minus 2 into y minus 2y, so it is 2x minus 2y into j cap plus 0 into k cap plus y into 3, 3y, 3y plus 0, that is 3y into k cap. This is your right hand side, and left hand side is minus 2 into I cap plus 2 into j cap plus 0 into k cap. Now if you observe this equation on left hand side as well as on right hand side, there is a vector in the form of I, j, k, and these two vectors are equal. It means that their corresponding components are equal. Corresponding components are equal means components of I cap, j cap and k cap are equal. So right here, by equality of vectors, in particular two vectors, minus 2 is equal to y, equation number 1. Component of j compare kara, 2 is equal to 2x minus 2y, give this equation number 2, and from the last one, here coefficient of k cap is 0 and here coefficient of k cap is 3y, so 0 is equal to 3y, give this equation number 3. See, from equation 1 we get y is equal to minus 2. From equation 1 we get y is equal to minus 2, and from equation 3 we get 3y is equal to 0, means if we divide throughout to this equation by 3, so 0 upon 3 0, 3 divided by 3 1, so y is equal to 0. Here we get two values of y, one is 0 and other is minus 2, so we can't get unique values for y, so therefore AB bar and AC bar, AD bar, these three vectors are not coplanar. This is not possible. Why this is not possible? Because we must have unique scalars. This is not possible. So therefore, AB bar, AC bar, AD bar are not coplanar. And these three vectors are not coplanar, means 4 points are not coplanar. Or this shows that the points A, B, C and D are not coplanar. So this is the solution for question number 13. So today we stop it here. Thank you.